Section 10.2a is about solving quadratic equations by graphing. Graphing is not the best way to solve quadratic equations. It's not the easiest, but by graphing them we learn a lot about them. So we're going to spend time doing that. Here a quadratic equation looks like this. We've already talked about that. An example of a quadratic equation that sets equal to 0 is one that looks like this. And in Chapter 9, if you remember, we used factoring to solve these types of equations. We had a trinomial, we made the diamond. But now we're going to take them and we're going to use graphing to determine the solutions of the quadratic equations. Now, just like in a linear equation that was equal to 0, the solution is the value that makes it equal to 0. Well, in a quadratic equation, the solutions have special names. They're called the roots of the equation. They're also known as the zeros because they represent the place where the parabola crosses the x-axis. So a little bit about that. The word solution, the word roots, and the word zeros, all three of these words are used to describe the place where the parabola crosses the x-axis. So if we look at this example, we want to identify the solutions of this parabola. In other words, where does this parabola cross the x-axis? Well, it crosses right here and right here. So we would say that the solutions here are x equals 1 to -3 and x equals -1. Those would be my two solutions, and you could write it this way. The two solutions of my parabola, where my parabola crosses the x-axis. And that's what we're finding when we're asked to find the solutions or the roots or the zeros. Here we have an example of a quadratic equation we're going to graph. This one is actually very difficult. There's some fractions in here that are kind of hard, and so please bear with me as we go through this example. First thing we want to do is find the axis of symmetry. So we use our formula opposite of b over 2a. In this problem, the b is -3, so we do opposite of -3 over 2 times 1, because my a is 1. That's going to give me a 3 over 2, so my axis of symmetry is 3/2. So I'm going to go over here to my graph, and I'm going to graph the axis of symmetry at 3/2. Well, 3/2 is 1.5. So I'm going to put this dotted line here at 1.5. Now I know my parabola is going to open upward, so I'm going to put that down here. X equals 3 over 2. Next thing I have to do is find the vertex, and we do that by plugging in the 3 over 2 for x and then solving it for y. So we're going to set it equal to y. And now we're going to solve this. And here's where it gets a little crazy. This is 9 over 4 minus 9 over 2 minus 10 over 1. And I make it a 10 over 1 so I can get a fraction here. Common denominators of a 4, so I'll multiply this fraction by 2 over 2 and this one by 4 over 4. So we get 9 over 4 minus 18 over 4 minus 40 over 4. Well, 9 minus 18 is -9. And -9 minus 40 is -49 over 4. And that's what y is. So we can say now that my vertex is 3/2, comma, -49 fourths. That's my vertex. Now -49 fourths is -12 and a fourth. So I'm going to go over here and I'm going to go down to 12, and about a fourth is right here. So that's my vertex, and I'll label it 3/2 and -49 fourths. I know that looks yucky, and it is kind of yucky, but it's not very difficult when we're trying to find the roots, because these fractions aren't my answer. Where it touches the x-axis, that's my answer. So the third step I'm going to do is I'm going to try some other x values. Well, let's go back to the graph. I could try 1 or 2. I could try that, but those are really super close to the axis of symmetry. So I'm gonna skip some. I could try 0 or -1 or whatever. Because I'm so far away from the x-axis, though, I'm going to try an x of -1. So I'm going to plug -1 in for my x, and again try to solve that. That's a +1 plus 3 minus 10. So that's a 4 minus 10 is -6. So when I plugged in -1, I got a -6 for my point. So let me go to my graph. Here's -1, here's -6. Because that's 2.5 units away from the axis of symmetry, that means there also has to be a point here, 2.5 units, and that's at 1, 2, 4, -6, and -1, -6. So that's 2 points. I still haven't gotten up here to my x-axis yet, so I'm going to keep going, and I'm going to try -2 is my next one. So -2 squared is 4, and this is +6, and that's -10. 10 minus 10 is 0. So -2x gives me a 0. So that's my next point. I'll go to -2, 0. And because that's 1, 2, 3.5 units away from the x-axis, I'm going to go 3.5 units this way, and that looks like 5, 0. And I've actually now found my 2 points where this parabola crosses the x-axis. I'm just going to sketch it in here just so you can see the parabola. This really isn't necessary because we've already found the 2 points, but I just wanted to show it to you. So the 2 solutions here in this parabola where it touches the x-axis are here at 5 and here at -2. So we'll say my solution is -2, 5. Here's our next example we have to graph. First thing you might notice is that it doesn't equal 0. That's a problem, so we're going to add 9 to both sides and actually get it equal to 0. So now we can do step 1, which is find the axis of symmetry, opposite of b over 2a. -6 is my b, and my a is 1, so we end up with a positive 6 over 2, which means my axis of symmetry will be 3. So x equals 3 is my axis. I'm going to go to my graph. I'm going to draw an axis of symmetry right here at x equals 3. I know it's going to open up, so I'll write it down here. Next thing I have to do, step number 2, is to find the vertex, and I do that by plugging in the 3 in for my x and solving for that. So plus 9. 3 squared is 9. 6 times 3 is 18. And let's see, 9 minus 18 is -9, plus 9 is 0. So my vertex is 3, 0. Go to my graph, and I'll put 3, 0 there. Now, remember what we're doing. We're trying to solve this equation. Now, when you solve a quadratic, you're trying to find the 0 points. You're trying to find the points where the parabola crosses the x-axis. Well, we've done it. That is where my parabola hits the x-axis. I can stop working because I know that my parabola is going to open up here somewhere. I don't even care what it looks like. I don't care if it's thin or fat. I don't care. I just know that the parabola touches the x-axis right there. It touches it in one spot, and that spot has a value of 3. So the solution to this quadratic equation is 3. Here's another example of graphing this quadratic equation. Start by doing the axis of symmetry opposite of b over 2a. In this case, my b is 2. Let's take the opposite of 2 over 2 times 1. Looks like -2 over 2 is -1. So my axis of symmetry is at x equals -1. Go to my graph, and I will put a dotted line at x equals -1. Now I'm going to find my vertex, and I do that by plugging -1 in for x and solving. -1 squared is 1. This is a -2 plus 3. So -1 minus 2 is positive 1 minus 2 is -1, and -1 plus 3 is 2. So you get the ordered pair of -1, 2. Go to my graph and do -1, 2, which is right here. Now, if I go back to my original, the leading coefficient is positive, so I know my parabola opens up. So I can stop working because I don't care if my parabola opens up here or here, if it's thin or fat again. I don't care because the question is, where does this parabola hit the x-axis? And the answer is it won't. It will never hit the x-axis because it's going to go up in the air forever. So we see the answer to this one is no solution.